Mic on.
Seven little jars, can't be right. Call my brother, he in prison doing time, but we alright. Tried my best just to catch a fucking smile, but for now I see myself ain't hitting the 35. Been awake for days, so we out living life in the night. Pray to God, man, I hope I don't die. Been awake for days, so we out living life in the night. Pray to God, man, I hope I don't die in the night. Lord knows, and I think I know it too sometimes. Every time, and I reach enough forwards mine. Lord knows, and I think I know it too sometimes. Every time, and I reach enough forwards mine. Lord knows, and I think I know it too sometimes. Every time, and I reach enough forwards mine. Lord knows, and I think I know it too sometimes. Every time, and I reach enough forwards mine. For days, so we out living life in the night. Pray to God, man, I hope I don't die. Been awake for days, so we out living life in the night. Pray to God, man, I hope I don't die in the night. Lord knows, and I think I know it too sometimes. Every time, and I reach enough forwards mine. Lord knows, and I think I know it too sometimes. Every time, and I reach enough forwards mine. Two bedrooms, seven little jars, can't be right. Call my brother, he in prison doing time, but we alright. Tried my best just to catch a fucking smile, but for now I see myself ain't hitting the 35. Been awake for days, so we out living life in the night. Pray to God, man, I hope I don't die. Been awake for days, so we out living life in the night. Pray to God, man, I hope I don't die in the night. Lord knows, and I think I know it too sometimes. Every time, and I reach enough forwards mine. Lord knows, and I think I know it too sometimes. Every time, and I reach enough forwards mine.
7, little just can't be right. Call my brother, he in prison doing time, but we alright. Tried my best just to catch a fucking smile, but for now I see myself ain't hitting the 35.
Been awake for days, so we out living life in the night. Pray to God, man, I hope I don't die. Been awake for days, so we out living life in the night. Pray to God, man, I hope I don't die in the night. God knows, and I think I know it too. Sometimes, every time, and I reaching out for what's mine. God knows, and I think I know it too. Sometimes, every time, and I reaching out for what's mine.
All right. Sorry. I'm trying to get all this stuff written down before I actually started. So what I'm doing right now, I'm just writing down all the properties that we've done so far. Give me like 2 more minutes to actually like finish it, and then we'll go over everything on the test. But for now, this is a good opportunity to kind of remind yourself of what we've been doing. So take your time kind of looking over this. This is everything we've covered. This is everything that has to do with logarithms and all of its properties. So this is really what the test is over. Okay, so if you really want to get down to it. So there's the definition up top. There's all of the properties that I just wrote. And then there's one more property that I got to do. And then we'll go over every question step by step. And try and hammer it out to make sure we understand it for tomorrow. Okay. Will we have to name what property is being used when we solve them? No, you don't have to. I'm just naming it for what it is. You don't have to tell me what you're using though. As long as you know what it is and what it looks like and how to use it, that's really what I care about at that point. Okay. So give me like 2 more seconds. I'll have everything written out, and then we'll go over the test. Okay. So I want to kind of go over this stuff real quick that I have written. First, logarithms and exponentials. That's what this entire chapter is over, and everything that you see written on this screen, that's what I'm going to be testing you on in some way, shape, or form. All right. Everything that we're doing is in order to use these properties effectively and be able to solve equations that are exponential or logarithmic in nature. All right. So our first kind of like definition, right, that's going to be up here. Right, these two things mean the same thing. So a to the power of x is equal to y. If that's the case, then log base a of y is equal to x. Right, the left is asking a to some power is equal to y, and the right is asking what power of a gives you y. Okay, so they're kind of asking the same question in different ways. One is asking for like the outcome of a to the x, and the other is asking for the exponent that gives you a certain number. just two sides of the same coin. All right. To the left of this, or to the right of this over here, all right, log base e of x is the same thing as ln of x. E is that kind of weird number, 2.7818, whatever. You don't need to know the actual number. You just need to know that for now it shows up naturally in a lot of different places. And natural log is used so much that it has its own notation for it. Okay. Besides that, everything that you see with ln works the exact same way as everything down here. Okay. Also, side note, I realized I've already started this stuff. This is all going to be found in your OneNote. All right. So if you go to content library, this is in that logarithms practice test. So this is going to be here for you. So if you miss anything, or you just need to sit down and like read it for a second quietly, that's fine. This is all there for you. But yeah, so that's, again, this is here for you. All right. So outside the definition of a logarithm and exponential, there are different properties for both, right? We've seen the properties of exponents. That's all the stuff in blue to the left. Okay. So we should know the product property, right? If we're multiplying two bases together, we are adding their exponents. If we are dividing two of the same base, if we're taking the ratio of those two things, we are subtracting their exponents. If we are taking a base to a power and then taking that to some power, okay, we're multiplying those exponents. And then what we started this entire chapter with was the one-to-one property. So if we have a to the x equals a to the y, then x must equal y. Right, and that's because of that equal sign. It's forcing the left-hand side to equal to the right-hand side, so their exponents must be the only thing that is the variable, and it's the only thing that, it's the thing that must be equal. Okay, and then the important part, the really important part, is the inverse property. And that says if we take a to the power of log base a, that just gets rid of these two things, and you're just left with x on the left-hand side. And then besides that, there's some kind of intro stuff. A to the power of 0 is always going to be 1, and a to the power of 1 is always going to be a. Okay. Everything on the left-hand side in blue has an analog in red, right? So the left-hand side is properties of exponents, and the right-hand side is properties of logarithms. Okay, so if we are adding two logs of the same base together, we are really multiplying their insides. If we are subtracting two logs of the same base together, that means we are taking the ratio of the insides, right? Keeping in mind that the left-hand side in blue is, it has an analog in the logs in red. Okay, right? So we are taking two bases, we're taking the ratio of those, so we're subtracting their exponents. So if we subtract logs, we're taking the ratio of the insides. Okay. If we have a power of a power, we multiply them. If we have a power on the inside, we can just take that out front and multiply it by the log. Then the one-to-one property, again, if you have log base a on the left, that modifies everything, and log base a on the right, that modifies everything. If those things are equal, the insides must be equal. Can we bring a note card with the equation? No, you may not. No, I'm testing you on whether or not you can do this right now. This seems like a lot, but again, if we know the left-hand side, which we should already know, the right-hand side isn't a stretch of it isn't a huge stretch. Okay. The inverse property, right? Again, if we take a log of an exponential, we're just left with that exponent. And then again, log base a of 1, that's equal to 0 because a to the power of 0 is 1. If we have log base a of a, that's equal to 1 because a to the power of 1 is a. Again, everything follows from the left, and that's all the stuff that you've already seen before. Okay, so this is what we're using. Okay, and we set the context of this with our equation. E is equal to p to the power, p times e to the power of rt And we also we actually started with this, which is kind of how money grows. All right. Then we looked at kind of the spread of disease and how that's exponential. So those are kind of the driving forces of why we would want to do this. All right. So with all that in mind, all right, I want to get to the test part. We'll go step by step, and I'll show you kind of what I'm expecting for tomorrow. All right. So again, this is in there for you. I'm going to erase some of this stuff so it looks a little bit cleaner, and then we'll go ahead and get going. So the first two questions, these should be the easiest things because they just go along with the definition, right? So remember the definition of an exponential and a log that says that if we have a to the power of x is equal to y, then we also have log base a of y. Oops, that's not how I want it. Log base a of y gives us the exponent. Okay, so on question 1, all it's saying is to rewrite the equation in exponential form. So we have a log and we want to rewrite an exponential. So we're going this way. All right. So if we have log base 7 of 343, that's equal to 3. That means that 7 cubed is equal to 343. That's all I'm asking you to do. On number 2, again, 4 cubed is equal to 64. So our base, right, that always goes down as our base of the exponent. The thing on the right of the equal sign, that's our exponent. And then the thing inside the log, that's what it's going to be equal to. Okay, so that should be easy enough. That's just our definition. In questions 3 through 6, I'm just asking you to take this a step further. And I'm asking you to evaluate each expression. Okay, so now you're not given the right-hand side. I'm just asking you to evaluate this number, right? So log base 6 of 36 is some number. And what this says is we have 6 to some power is equal to 36. Okay, so what do you have to do for 6 in order to get to 36? Well, we just have to take 6 and square it, right? So this thing is equal to 2, right? Because 6 squared is equal to 36. Same thing for number 4, 5, and 6. All right. So 3 of log base 3 of 243. That's asking what power of 3 gives us the 243. Well, 3 times 3 is 9. 3 cubed is 27. 3 to the 4th is 81. And then 3 to the 5th is 243. Okay, so our answer here is 3. And you can, again, you can check this on a calculator. If you go into that math menu and scroll down, there's a log base button. And you can plug it in. And that'll give you something that looks like log, little box, big box. And you can just plug in numbers. Okay, but I would expect you to write something like this just so I know your thought process. All right, number 5, log base 5 of 125. That's saying 5 to what power is 1 over 25? Well, our 5 is in the denominator, right? So we have 5 to the power of x is equal to 5 to the negative 2. So x must be equal to negative 2. That's using a little bit of the one-to-one property. Okay, but you'd have to square 5 to get 25, and then 25 is in the denominator, so that must be negative. Log base 4 of 64, 4 to what power is 64? Well, 4 times 4 is 16, times 4 is 64, so x is equal to 3. Okay. So again, well, 1 through 6 should be relatively easy. 3 through 6 might require a little bit of thought, but they should be really, really straightforward. Okay. 7 and 8, we are condensing each expression. Okay, so that goes back to the notes that we did above, or that we have above. Okay, so we're going to be using a mixture of these things right here. All right, so we're going to use the product property, the quotient property, the power property, and we're using those in order to condense our equation. So number 4, this is really a couple of questions in one. Okay, we want to condense this part, then we want to condense this part, and then we want to condense the entire thing. So 4 times log base 4 of x. Okay, whenever we're multiplying by a constant on the outside, that means that's the exponent on the inside. And then the same thing for the right part, right? So this is going to be log base 4 of y to the 12th. Right, and when we're doing that, we're using the power property, right? Just so we can see it. All right, that's the power property. Okay, so we did that part of the problem, and then we have to condense this entire thing. And in order to do that, we're going to use the quotient property, which says that when we have the difference of logs with the same base, we are taking the quotient of their insides. So this is going to be log base 4 of x to the 4th over y to the 12th. And then this is as condensed as you can get it. All right, and that quotient property, just so it's right in front of you, log base a of x minus log base a of y. That's equal to log base a of x over y. Okay, so if we use this again on number 8, keep it in mind we could use the product property too. So just for the sake of like argument, I'm going to make this a plus. All right, it's the same idea. We're just using a different property here. But the first part is the same, right? So we can condense this part and we can condense this part, right? So log base 8 of x, 4 times log base 8 of x is equal to log base 8 of x to the 4th. 20 log base 8 of y is log base 8 of y to the 20. And then we have the sum of two logs with the same base, which says we can use the product property, which means we can use the product property, which says that if we have two logs with the same base and we are adding them together, we can multiply their insides. Will the test be the exact same format, just with different numbers? Yes. I would plan for at most this test. I might cut off a couple of problems, most likely in this section. Okay, I kind of felt like 6 of these was a little bit overkill, but I want to get a good idea of what we can do. All right. Okay, so condensing, that's number 7 and 8. Again, the rules are right here. And then we're just using those rules in order to condense our equations as much as we can. And the reason that's important is to solve things like we have in numbers 9 through 14, which we're going to get to here in a second. Okay, number 9 says log base 15 of 4x plus 9 equals log base 15 of 3x plus 7. All right, so when we're doing these, especially number 9 and 10, 9, 10, and 11, right? So 9 through 11. We're going to use the one-to-one property. Which again, that says that if we have two logs with the same base are equal to each other, and that's the only thing modifying the left and right hand side, right? So it's just log A on the left and just log A on the right. We can just take their insides and set them equal to each other and solve. Okay, so on number 9, we have two logs with the same base. That base is 15. Okay, and that's it on the left and that's it on the right, which means we can just ignore these two logs and have 4x plus 9 equal to 3x plus 7, and then solve like we would normally do in a regular algebra problem. Did I finish 8? No, I did not finish 8. But we would just use that product rule. So we'd get log 8 of x to the 4th over y times y to the 20th. That'd be as condensed as that can get. Sorry, I forgot about that. I'll try and leave that in sight so people can see it. All right, number 10 is the same way. Okay, log base 20 modifies the entire left-hand side. Log base 20 modifies the entire right-hand side. So we just ignore those logs, and we set the insides equal to each other. Add 3x to both sides, so we get 1 is equal to negative x. So x is equal to negative 1. And on number 9, sorry, I keep going out of order, x would equal negative 2. I'm going to stop there so people see all that work for like a minute. Okay. Number 11 is where it gets a little bit trickier, but it only gets trickier in the sense that we have to do a little bit more algebra. Okay, so number 11, we're still going to use the one-to-one property because log 4 modifies the entire right-hand side, and log base 4 modifies the entire right-hand side. Okay, so log 4 modifies all of the left and all of the right. So we can ignore those, and we can set k squared minus 9k equal to k. Okay, now when we're doing this, this might seem relatively easy, but we're dealing with a quadratic now, so we have to kind of shift our focus away from linear equations into quadratic equations. All right, so when we have a quadratic, right, this square, we need to move everything to the left and set it equal to 0. So if we subtract k from both sides, we get k squared minus 10k is equal to 0. And then we have to solve this expression. We have to solve this equation. Okay. There's two different ways we could do this. We could either use the quadratic formula, or we could factor. Okay. Quadratic formula in this case seems a little bit too much because this is just a binomial, right? There's two terms. So we can factor out our greatest common factor and make it simple, right? So the greatest common factor between k squared and negative 10k is just k. And if we take k out of both of those, we get k minus 10. And when you have a product of two things that's equal to 0, one of those two things must equal 0. So either k is equal to 0 or k minus 10 is 0, in which case k would equal 10. Okay, so this is where I'd expect you to get. Actually, only one of these answers makes sense. You can't have 4 to some power give you 0, so really this answer doesn't work. I'm hoping that it makes sense to you why it doesn't work, but I'm not going to be testing on that, right? Because if you have 4 to some power gives you 0, there's nothing you could plug in there, right? And that's what that would say. All right. Number 12 is where we start to get away from the one-to-one property just a little bit. Okay, so there's work that we have to be done first. And a question like number 12 is where we can ask ourselves what operations are on X. Okay, so if we just listed those, our strategy would be to list the operations on X and then just undo all of those operations, right? So the first thing on X, if we just focus on the X, is multiply by -5. The next operation would be to subtract 5. Then we would take the log base of 5 of all of that. We would multiply that by -7. And then we would add 6. So in order to solve, we would just reverse this order and invert all of these operations. So the first thing we do is sub 6, subtract 6, divide by -7. And then this is where, like, this is like the core. So like everything up until this point and even after this point is all just algebra. And this is the logarithmic part. But we need to undo log base 5. And up above, I believe I said, or at least I've been saying this a lot in class, logs undo exponentials and exponentials undo logs. Okay, so if we have log base 5 as a modifier, in order to do that, we want to take everything to the power of 5. So we want to take everything as an exponent of 5. And then after that, we just continue to undo those operations. So then we would add 5. And then divide by -5. So when we do that, we're going to subtract 6 first. So we have -7 log base 5 of -5x minus 5 is equal to -8 minus 6, which is -14. Yeah. We would divide by -7, so we get log base 5 of all this stuff on the inside is equal to 2. And then we want to take all of this entire thing, as an exponent of 5. Okay? So you don't necessarily have to show this on a test, but what this would look like is 5 to the power of log base 5 is equal to 5 squared. And what that does, 5 to the power of log 5, that just cancels out. So you're left with -5x minus 5 is equal to 5 squared, so 25. Then we add 5. And then divide by -5. And that gets us our answer. So again, everything is algebra, except like this step right here. Well, it's all still algebra. It's just there's a difference between what you've been used to doing and then what we're doing now. Okay. Number 13 and 14 are almost the same, except now we have to worry about condensing. Okay. So on the left-hand side on number 13, we want to condense the entire left-hand side into one log. And the reason we're doing that is because we can do, once we have one single log, we can do exactly what we did in this equation, or in this problem. Okay, so we need to condense this. So we need to condense two logs with the same base that are being subtracted from one another. So we're going to use the quotient property. Okay, so we're going to have log base 4 of negative 5x over 3 is equal to 1. And then we could go through this and then list those operations on x again. I'm going to do it really quickly. So we want to multiply by negative 5, divide by 3, and then take the log base of 4. So what we need to do is we need to invert log base 4. So we're going to take everything as an exponent of 4. Multiply by 3. And then divide by negative 5. I'm not expecting you to do this on the test, by the way, but it does help kind of get through some of these questions. All right, so when we do this, we're going to get negative 5x over 3 is equal to 4 to the first, multiply by 3, so we get negative 5x is equal to 12. So x is 12 over negative 5. On number 14, we're kind of doing the same thing, except eventually we're getting to the point where we can use the one-to-one property. So we need to condense this left-hand side. And when we do that, we get log base 5 of 4x minus 16. Right, we're multiplying this set of parentheses and this set of parentheses. And then that's equal to the left-hand or the right-hand side. And then you should notice that you have log base 5 modifying everything on the left, log base 5 modifying everything on the right. So those can cancel. And we're left with 4x minus 16 is equal to 16, which means that 4x is equal to 32. So x is equal to 8. Okay, so that's like the core stuff that we're trying to work on. That's logarithms, or sorry, that's exponentials undoing logarithms. And now we can kind of work the opposite way a little bit. Yeah. So on numbers 15, 16, 17, and 18, all we're worried about is changing these bases so that there's a common base on the left hand and right hand side. Okay. So on number 15, the common base here would be 4. And that takes practice to kind of understand what that means. But basically 4 to some power can give you 16, can give you 4, and can give you 4. So I'm going to condense the left-hand side. So that's 4 to the power of b plus 3 minus 3b. So we have negative 2b plus 3. And then on the right-hand side, we can rewrite 16 as 4 squared. Then we can use that one-to-one property, cancel out those bases. Negative 2b plus 3 is equal to 2. So negative 2b is equal to negative 1. So b is equal to 1/2. On number 16, there's a little bit more work to do. The common base here, again, is 4. Right? We can rewrite 1 over 16 as 4 to the negative 2. And then there's that 3a on the outside. We can rewrite 16 as 4 squared. That's the power of 2 minus 3a. And then we can rewrite 64 as 4 cubed. Okay, but we're not done yet. We have to still simplify exponents, right? So 4 to the negative 2 to the power of 3a is 4 to the negative 6a. 4 squared to the power of 2 minus 3a. That's 4 to the power of 4 minus 6a. And then we have to condense these two things into one, right? So we're adding exponents. So this is going to be 4 minus 12a is equal to 4 cubed. And then we have a common base on both sides. So 4 minus 12a is equal to 3. So negative 12a is equal to negative 1. So a is 1/12. Number 15 and 16 are actually harder than number 17 and 18. 216 and 1/6, the common base is 6. So let's see, 216 is 6 to the power of, squared is 36, times 6 is 216, so 6 cubed. So 216 is 6 cubed, and then there's the power of 2x. 1 over 6 is 6 to the negative first. Then we have 6 to the power of 6x is 6 to the negative 1, which means that 6x is equal to negative 1. So x is negative 1/6. One over 9. I was helping someone with this earlier. This is a little bit trickier because we actually need this in the power of 3. So 1/9 is 3 to the negative 2. And that's the power of m. And 243 is 3 to the power of, so that's 81, times another 3, that's 3 to the 5th. Again, you're going to have calculators that can help you. I know this because I've done this a couple of times. And then we can condense things. So 3 to the power of negative 2m is equal to 3 to the 5th. So negative 2m is equal to 5. M is equal to negative 5/2. And then the last problem, number 19. So number 19 requires you to use this equation. That's the amount, the final amount is equal to our principal value times e to the power of our rate times time. So really we're just, to start, we're just plugging in numbers, right? We want our $15,000 principal value to grow into $30,000. That's our amount. And then we have a rate of 7.5. Okay, so if we just plug numbers in, we get 30,000 is equal to 15,000 times e to the power of our rate, which is 0.075, times time. And we want to see how long it takes for this to happen. So we want to see how long it's going to take our money to double, all right? And in order to do this, all we're doing is we're solving this exponential problem. So we're solving for our variable. What you could do is, again, you could list operations on, in this case, t. So t is being multiplied by 0.075. That's that 7.5%. That's taken to the power of e, so exponential e. Multiply by 15,000. And in order to undo this, right, we need to revert the order. So we need to invert, so reverse and invert. In order to invert multiply by 15, we divide by 15,000. The inverse of exponential is logarithmic, and if the base is e, we want to take log base e on both sides. And all that means is we're taking the natural log. So these two things are the same. And then we divide by 0.075. So what this looks like, we divide both sides by 15,000. We take the natural log of both sides. All right, 30,000 divided by 15,000 is 2. And when we take the natural log of the right-hand side, this log base e and this e cancel. So you have ln of 2 is equal to 0.075t. So then t is equal to natural log of 2 divided by 0.075. And you can plug this into a calculator, which I would encourage you to do because it makes more sense that way. But that'll give you a number of years that it would take to double your income. Okay, so that's every question on the test, step by step. And I think as best a way as I can explain it. But I want to pause for a second and make sure people don't have questions. So I'm going to mute myself. I'm going to scroll back up, and I'll kind of slowly scroll down. On number 15, why is 4 over 4 equal to 4? It's not 4. Wait, on number 15, my bad. 4 over 4 is not equal to just 4. So let me... We have 4 to the power of b plus 3 over 4 to the power of 3b. Okay, so we have the ratio of two bases, of two of the same base. So this is equal to 4 to the power of b plus 3 minus 3b. which is equal to 4 to the power of negative 2b plus 3. So that's the left-hand side. The right-hand side is 4 squared. So we can cancel out those bases. And then we have negative 2b plus 3 is equal to 2. Subtract 3 from both sides, so we get negative 2b is equal to negative 1. Divide by negative 2, we get b is equal to 1/2. So I'm not sure what you mean by 4 over 4 is equal to 4. Okay, I'm going to leave this open for another like 2 minutes. Okay, so if there's no other questions by 8:24, I'll shut this down. But if there's questions, I'm happy to help. All right, otherwise, this will be up shortly. If you're just getting here or you didn't see the entire thing, if you just leave this open, you can always kind of rewind and pause and all that stuff. If you exit out, usually it takes a little bit for it to go up. It'll definitely be up tonight, but sometimes it just takes a couple minutes, so it doesn't show up immediately. All right, so I'm going to pause myself if there's no questions in the next 2 minutes, then I'll shut it down, and I'll see you guys tomorrow. All right, it is 8:24. There's been no questions. So again, this will be up shortly. Again, if you're already on the link, you might as well just stay there, and you can pause and rewind and all that stuff. All right, but since there's no questions, I'm going to shut this down, and I will see you guys tomorrow. So thank you for coming, and we'll test on this tomorrow. So good luck.